going to finish up. Try now 18, question 3. Try now 18, question 3. Right, so you've got these 3 villages, A, B, and C. In a way, we just have to complete them a little bit more to understand what's going on. That angle of depression there is 20 degrees, and here the angle of elevation is 30 degrees. This is 8, and this is 12. So in the first place, we have to calculate this height here. Now, this will then also be 8 to do that one. So which function will I use? This is then the opposite and the adjacent, so it will be the tan function. So tan 20 degrees is then equal to the opposite that you want to calculate over 8. Which method? Top times, which is then 2.9. Number B. Now the vertical height between B and C. Again, this is the opposite. This is the adjacent. Which function? Tan 30 degrees is equal to opposite over 12. Which method? Top times. And the answer is then 6.9 there. Then at number C, I have to find the angle of elevation of C from A. The angle of elevation of C from A. So I need to find the distance, and the distance between these two is then 4. I subtract the 2 then there. Now the angle of elevation of C from A. So which method will I use there? Tan theta, that's that angle of elevation that you want to calculate. And these 2 sides that I'm going to put on top of each other is then 4 over 20. How do I get the 20? 12 plus 8. So 4 over 20 there. How do we get angles? Which method? Second function tan, and the answer is 11.3. 11.3. And then they say the shortest distance between A and C. The shortest distance between A and C. Now, if we look at the picture, the shortest distance between A and C will eventually be that distance there. That would be the shortest one to get then there. And I will do that with Pythagoras. Number D, I will do that with Pythagoras. And the answer is then 20.4. 20.4. Right, the next question, number 4. So again, you've got those boats. They love to ask this kind of question with the boats and the different angles of depression. Now, this angle of depression here is 10 degrees, eye level downwards. And this one is 17 degrees there. From the top of a lighthouse, 7.5 meters high, so there's the lighthouse, a man sees 2 boats at the sea in front of him. The angle of depression of A is 17 and of B is 10. Calculate the distance between the 2 boats. So eventually, we want this distance here between those 2. But to get there, we'll have to find this length and then subtract the 2 from each other. Now remember what we said, these angles of depression are outside the triangle, so we must work with them inside the triangle. So this is alternating, which means this angle here will be 17 degrees. And this one is alternating here, so that angle there will be 10 degrees. Which function will we use? This is obviously tan. So we can say that tan 17 degrees is then equal to 7.5 over this length here, We can call it the adjacent side there. And which method will it now be? Bottom divide. It would be bottom divide. So on your calculator now, we press 7.5 divide by tan 17 is equal to, and I got 245.31. So 245.31. And then the second one, so now we're going to do the big one here, so that will then be tan 10 degrees is equal to 7.5, that side, over the whole one here. Now we want that one. Which method? Bottom divide. So it is 7.5 divided by tan 10 is equal to 42.534. 42.534, point is here, and then the point is there, and then if we subtract the two now from each other, we get 18 meters. 18 meters in there. Right, the last question, question 5. So there you've got a tower here, and there's another one there, 2 towers that we have there. TW is the tower opposite a building, 30 meters high. The building there is 30 meters high. The angle of elevation of T from B is 33 degrees. This tower is higher. So the angle of elevation here is 33 degrees. And then the angle of depression of W from B is 29 degrees. So the angle of depression should be now here. This one is 29 degrees. The angle of depression, can you see? Eye level downwards. And now we say, find the horizontal distance between the tower and the building. The horizontal distance between the tower and the building. So the horizontal distance is, this is what we want to calculate between the tower and the building then there. And so which function will we use? Now, this angle alternates with this one, so that one is 33 degrees there. Here we've got the building's height. So we can calculate that WD. We can calculate that one then there. And so the angle is 61 degrees. That one in the triangle is then 61 degrees. So then I can say that tan 61 is equal to WD over 30. Which method? Top times. So if we multiply the two, it is 54.1 meter. And then the second one, number B. So now we want to find tan N. So it's tan 33 this time is equal to Tn over that 54 point, and I should use that unrounded one there, 54.1, which method? Top times, and that is then 35.133. And then I can add the two. My final answer is 65.1 meter. 65.1 meter. Right. Now we're going to continue with number 19. And we're first going to look at 3-dimensional stuff. So you have to understand this inside a box that are working with 3 dimensions, and that sometimes we'll have to get a base. So for instance, if you have this pyramid is standing then on that square base. And then if we want to find that angle there, you have to draw a little triangle. So the secret is to always draw the little triangles that you are working with, and then we'll understand better which sides we are talking about here. So if you look in your textbook, this is now on page 457, page 457, where we find the 3 dimensions. There's a nice example on that page there. Look at the original square-based pyramid that we have. And then, as we say, every time draw the little triangle that you want to work with, because then you can see which sides are which one. They did that with PB, then also in the second triangle, and then look there at the last one. That's where you get that 3 dimensions. The important thing is always to find your 90 degree. Where is the 90 degrees? Then it makes it easier. So we're looking now at try now 19 on page 458. And I will use this exercise to explain. And then I want you first to do 20 before you start marking number 20. Right, number 19. Now, it's not so easy to make those drawings there every time. So you've got this pyramid on a square base there. Vertex V is at the top. There's the vertex V. Okay. Now we want to find VCB. And that's why I'm going to draw that little triangle there. V is at the top. Where's the 90 degrees? At B. Can you see that? And there's C. The moment when we have that, it becomes much more easier. It means this side BC will also be 5 centimeters then there. And they also gave us the figure there. DC is 12, AD is 5, and WB is 3. This is the other one that we need then there. That height there is 3. Okay, now we have to calculate VCB. VCB means we want C. We want angle C. That's the one that you want to calculate. So, let you add to the angle which function. This is the opposite and the adjacent. So it's still that right angle triangle. So tan, and tan C is then 3/5, second function tan, and the size of C is, I got 31 degrees. Right, number B. Now they say we want to find VDB. So again, I'm going to draw my little triangle, V. Now it's VDB. Where is the 90 degrees? It is still at B. It will still be at B, and there's D. Which information do we have? We know that VB is 3. We've already done that one. But I don't have BD or VD. But I can calculate BD with Pythagoras. Can you see there? If you look there at the base, then to calculate BD, I can use Pythagoras, calculating that third side. So that means BD is now going to be 12 squared plus 5 squared. 12 squared plus 5 squared. That is BD. And then we can calculate, and this gives you, it is 13. So now it's possible to calculate VDB. I want the angle. This is the one that I want to calculate. So I'm going to use again tan. Tan D is then 3/13. But I need my little triangle. Then it is very easy. Second function tan 3/13. And I got that the angle is 13 degrees. 13 degrees. Right, question 2. Let's look at it again. I'm explaining at this stage. It's again that same thing of a square-based pyramid where you have these lines in there at the top. This one is 12, This one is 9. The height here is 8. That's the given information. Calculate the angle of elevation of V from B. Of V from B. So I'm going to draw my little triangle. There is V. Where is the 90 degrees in this case? At A. And there's B. The 90 degrees is at A. Look at the original picture. This one is then 8 and this one is 9. So the angle of elevation of V from B is this one. That is your angle of elevation. So I can say that tan theta is going to be 8/9. Which method? Second function. Angles is also always second function. And the angle is 42 degrees. Look, they say in this case to the nearest degree, so I have to round it off. Number B, show all your working to prove that VC is 15. Now, VC is 15. Again, let me draw that little triangle then there. VCB. Okay, and now I have to show that this one is 15 degrees. So I actually first have to get the hypotenuse there. So in the first place, we will then say 9 squared plus 12 squared, and this is going to give us 15, and then 8 squared plus 15 squared, and that gives me 70. That's how I will show it, working in those smaller triangles. Now, I want you now first to try now 20. First do the exercise. This is on page 459. And then you can mark it. Otherwise, it won't help if you don't try. Right, number 1. The figure shows a pyramid with a rectangular base, the vertex V. We've got those sides there. Find the length of CM, the first one. Now, if you look there at that base, CABD, and M is now right here in the middle. So I can say that CM is going to be a half of AC. I first need to find AC. This one is 8 and this one is 6. So I can say that AC is then equal to 8 squared plus 6 squared. You can see we use all our trigonometric knowledge at this stage, and that will give me 10. A half of 10 is then 5. So CM is equal to 5. That's then half of that one. Now at number B, they want the height VM. Now I'm going to draw my little triangle. There is V, there is M, there is C. So, what lengths do I have? We know that I have to find VM now. I know that CM is now 5, and I know that that side is 13. It's given to me there. Can you see? The little triangle helps you a lot. So now that will just be 13 squared minus 5 squared, which is 12 centimeters. And then the last part there, number C, says the angle between CV and the base ABCD. So we can work in the same triangle here. The angle between this and the base here, which is now here. So this is the angle that I want to calculate. And actually you can use now any function, because we know that one is 12, so you can use sine, cosine, or tan. Doesn't matter. Just the correct ones. I've chosen cosine. So cosine theta is then 5/13, that included angle, and theta is equal to 67.4 degrees. It is a good idea to use the given information in a case like this. Number 2. So this time we've got a cuboid there. Okay. The cube of length 10, so all the sides are 10 there, and in the first place we have to find M-E-N. M-E-N. So I'm drawing that little triangle M-E-N. So E is there at the top, N is the 90 degrees, and that is M. You have to draw that little triangle then there. Okay? So this side is 10. This one is also 10. Now, this one won't be 10 because this is the midpoint, isn't it? So this one will be 5. That one is 10. And the question is now find M-E-N. That is the angle that we want to calculate there. Which sides do you have? Tan. So tan E is equal to 10 over 5. Look, this is the opposite, and this is the adjacent. Which method? Second function tan, and I got 63.4 degrees. Number B. Now we want E-M-N. E-M-N, now that's easy because we've got it now. They're in the triangle. We can just subtract it from 90 degrees, and that is 26.6 degrees. That one is 90, so you just subtract that one. Number C, M-E-F. Okay, now look at the picture. M-E-F. So I have to draw that triangle. E and F, and M is here. So what lengths do we have? This one is 10. No, this one is again 5 because it's the midpoint. M is the midpoint. So that one is 5. This one will be 10. And now we have to find the angle MEF, this one. So again, it is the tan function. Tan E is equal to 5 over 10, second function tan, and the angle is also 26.6 degrees. And then the last one is to find DB. DB, and we can do that with Pythagoras, because we have to find the angle now between HB and the base. So I will first find DB, which is then the square root of 200. And then to find that angle there, I can say that tan theta is going to be 10 over the square root of 200. This is 10 squared plus 10 squared, and my answer is 35.3 degrees there. Question 3. It's again that square-based pyramid. As you can see, they love that kind of question there. Okay, but I'll rather work with the small triangles. So it says there it's a pyramid. M is the midpoint of BC. N is now the midpoint of AC. So in the first place, we have to find EM. So I'm drawing my little triangle, EM, and look there, the 90 degrees is at N. Always find that. Right, so what do we have? We know that EC is 15, but we're working now with EM here. M is the midpoint, and those sides are 10 centimeters. So we have to find the length of EM. So it means this will be 5, because it's a half of 10. That's how I get that. NM is a half of 10. That's how we get that height then there. And we have to find EM now. So what other information do we have? What is the height? Have they given us the height there? Okay, so the length of EM is then 15 squared minus 5 squared, which is then 14.1. 14.1. That's one. Then 15 minus 4 squared. So that's how we get EM. And then the next one is number B. Now we can say that EN is then equal to the 200 minus the 25, or the squared minus the 5 squared there on that side. This is the square root of 175, which is 69.2. Sorry, 13.2. Sorry, 13.2. That's how we get that one. Then number C. And now they want EMN. So look at your sketch again. EMN. So I want that angle now there. EMN. So I'm going to say this is cosine M is then equal to 5 over that 14.1. Second function cosine, and the answer is 69.2 degrees on that one. Then number D, and number C. This one is up to number C. Right, the next question is question 4 then. Question 4. The wedge, look at that picture there. We've got the different information there, and in the first place, we want to find BS now. So there is my triangle, BS. This one is 2 and this one is 4. So that is very easy. We can just do it with Pythagoras. 2 squared plus 4 squared. And my answer is 4.47. Number B. Now they want AS. AS. Now the triangle that I have now is ASR. Can you see? That's where I'm working with now there. And first I can find AR. This is here. So if you look now at the original one, that is the hypotenuse. So I first have to calculate that one, and that would be 6 squared plus 4 squared. I first need to find that hypotenuse AR there. And that is, I got here that is the square root of 52. Square root of 52 there. Remember the 90 degrees is now there at S. So now to find AS, that one is 2. So to find AS, we can say then that is the square root of 52 minus 2 squared in that root. And I got that it is 7.48. 7.48. Right? Question C. Angle SBR. SBR, so this is still in this triangle. SBR. There you are. So that's easy. It will be tan theta, which is 2 over 4. And I got 26.6 degrees there. And then the very last one, number D, ASR. So now we're working in this one, ASR. And that will then be tan. And that is the square root of 52 over 2. And I got 74.5 degrees for that one. So the secret of three-dimensional ones is to draw that little triangle every time. Drawing that little triangle.
inside the box. Referee has a look. It's a penalty. It's Ronaldo. It's three. It's the record-equaling hat-trick of Cristiano Ronaldo's career.
With over 300 games in 6 weeks, get DSTV to watch the best live football action.
We're continuing then with trigonometry, and today we're going to look at angles more than 0 to 90 degrees. So let me just first explain to you what we have here. 0, this is 90 degrees. We call this quadrant 1. Quadrant 2, 180 degrees, 270 degrees, and then obviously when you're back here, you're at 360 degrees. So this is the direction that we go around here. This is quadrant 3, and this is quadrant 4 that we're going to talk about now here. Now, what we've done up to now is working in a right angle triangle. And this is your x value, this is your y value, and we call this r the radius. So if I go through the functions now, you don't need to write this off, just listen, and then we'll get to a summary after that. So if I want to find sine theta, there's my theta angle down now there, then it will be y over r. If I want to find cosine theta, then it is x over r. And tan theta from here is then y over x. So what we see from that is that all my functions are positive in quadrant 1. Now, if we go over to quadrant 2, this is still theta, so this is y. X will now be negative because it's negative on the x-axis. And your r is always positive because you square it, so those answers are positive. Now, if I write the functions now here, then I can say sine theta is y over r, cosine theta is negative x over r, and tan theta is y over negative x. Right, if I go in the next quadrant, let's make this one a blue one, there's theta. So now y is also negative in that case there. So in quadrant 3, sine theta is going to be negative y over r. Cosine theta is going to be negative x over r. There you have it. And tan theta is then negative y over negative x. If we go now here to the last one, there's my theta. So y is negative here and x is positive there. So in quadrant 4, sine theta is negative y over r. Cosine theta is equal to x over r. And tan theta is negative y over x. Now, from this, we've said now that in quadrant 1, all of them are positive. All of them. If we go back to this one, then you will see sine is here positive in quadrant 2. If we look in quadrant 3, then this one is going to be eventually positive y over positive x. So tan is positive in quadrant 3. And in quadrant 4, sine is negative, but this time cosine is positive. So from there, we go now to what we call cost. Cost. And you can summarize this in your book, cost. This is what we need to understand now there. So for cost, here, this is cosine, all sine, tan. Cost. Cost. Okay, this is what we need to remember. Can you see? Where, in which quadrant are they? Positive. And then the second thing that we have to understand is how do we get those angles? And I call it the butterfly story because it looks like a butterfly here. Can you see? So this angle is 180 degrees minus theta. This one, to get this one, now remember, this is actually the angle that I want to find here, that one there. So then this one is 180 degrees plus theta. And the last one is 360 degrees minus theta. You will go right around 360 degrees minus theta. So this is how we're going to find those angles. This trigonometry is also a topic in your higher level next year. It will be very important, and this is the basic that we need to understand to do this. Now, let's look in the textbook. You will see that is what you have on page 460 and page 461. This is now where we are. And they're explaining everything that I did now also there. So I want us now to look at try now 21. And you can just first listen and follow what we do. Now they say, given that sine theta is equal to 3 over 5, find the value of cosine theta and tan theta between 0 and 360 degrees. Now, if we draw this one, then this is 3, this is the opposite, and this is the hypotenuse. That's your cosine, your sine one there. To find cosine, we will then have to calculate this one. You can do that with Pythagoras, 5 squared minus 3 squared, which is 4. So I can now say that cosine theta is equal to 4 over 5. And tan theta is equal to 3 over 4. That is my ratio of these angles that I can get out there. Okay, so this is now where they are positive. The next one, number 2. Tan A is equal to negative 5 over 12. Find the values of cosine A and sine A. So again, it is a good idea if we draw this. Negative 5 over 12, where will this one be? Where it is negative 5 on the x-axis and then 12. So it will be here, negative 5, and 12 is the opposite. There's your theta. We're still working in that right angle triangle there. So now first we have to find the hypotenuse here, which will again now be 12 squared plus negative 5 squared, and that is 13. So then I can say that sine A is equal to 12 over 13, positive, and cosine A in that quadrant is then going to be negative 5 over 13. Negative 5 over 13. Right, let's look at the next one, number 3. So now we have negative 4 over 5, cosine B. So negative 4 over 5. There's my theta. So I first have to calculate this one, which will again be 5 squared minus negative 4 squared. And the value of that side is 3. That's your typical Pythagorean triple that we are working with here. Okay, and then we have to find sine and tan. So sine theta is then going to be 3 over 5. And tan theta is going to be 3 over negative 4. 3 over negative 4. Question 4. Now, this one is square root 3 over 2. Cosine is positive. Find sine x if cosine is a reflex angle. Now, cosine is positive here in this quadrant. So it will then be, now here, this is square root 3. And this is 2, the hypotenuse then there, cosine. So if I have to give sine now, again, I'll first have to calculate this angle, which is then 2 squared minus the square root of 3 squared. Just look at that. Those two will cancel out. So it is then 4 minus 3, which is 1. And the square root of 1 is 1. So then I can say that sine theta is 1 over 2. And tan theta is then opposite over adjacent. So it is 1 over square root 3. 1 over square root 3. And the last one, number 5. So they say 15 tan theta minus 8 is equal to 0. So with algebra, we first change this one now to tan theta. We take the 8 over, so it becomes positive, and I divide by 15. So there is my ratio then there. And without using a calculator, we have to find the values now there. So let's first again draw the picture. Tan is positive, so it is 8 over 15, which means now there's theta. So this is the opposite 8, and this is then the adjacent 15. There. So first we have to calculate this one, which is then 8 squared plus 15 squared, and this is 17, right? So now we have to find tan squared theta. So then we can just, so this one, tan squared theta is equal to, so we just have to square those two there. They don't want the angle. So this is then 64 over 225. The second one is sine squared theta plus cosine squared theta. And this is equal to 1. This is a formula that we learn. And then we have sine theta divide by cosine theta. Let's just look at this one. What is sine theta now here? Sine theta will be 8 over 17. And then we divide it. And what is cosine theta? Cosine theta is 15 over 17. So then it's 8 over 17 multiply with the reciprocal, which gives us then 8 over 15. The 17s will cancel out there. Right. Now, there's some more explanations on page 462. And now we're looking at try now 22. Try now 22 on page 462. Okay, so this is now working. The two things that we work now with is cast and the butterfly story. This is what we're going to deal with now here. Cast and the butterfly story. Remember we said this one is 180 minus theta, 180 plus theta, 360 minus theta. That's what you're using now. Right, number 1. So we say cosine x is equal to 0.5. Just look at the range. It's now not 90 degrees anymore, but it's 0 to 360 degrees. That is what we're working with now here. First, listen to a few, and then you can try them. So in the first place, we're going to get this angle, and to get it with your calculator, second function cosine 0.5 is equal to 60 degrees. Now we talk about the key angle. This is the key angle here. And now from there, I like us to draw cast and the butterfly story. So where the question is now, according to cast, where is cosine positive? And cosine positive is there, all, and also here. That is where it's positive. Now I use the butterfly story to get those angles. So that one is 60 degrees. That's your key angle. And how do I get this one? With the butterfly story, 360 minus theta. So this one will be 300 degrees. And then we write final solution, 60 degrees and 300 degrees. Because sometimes there's going to be extra angles, so you must indicate which ones you choose. Number 2. Sine x is negative 0.6. Sine x is equal to negative 0.6. Now the negative indicates the quadrant. Don't press that one now. That indicates the quadrant. So now we're going to say second function sine 0.6 is equal to, and I got 36.869. 36.869. I don't round off now. I will round off in a final step. So first go for 5 significant figures. If we draw this one now there, according to cast, if we go back now to cast, now this time sine is negative. That negative is not a negative angle. It indicates the quadrant. So where is sine negative? There is sine positive, so this is where sine will be negative. So it will be here. Now this angle is my key angle here, 36.869. But that's not the solution. I need to find those two. How do we do it? We use the butterfly story. So 180 plus theta and 360 minus theta. So on your calculator now there, 180 plus 36.869. And now I'm going to round off to 1 decimal place, my angles, and I write my final solution. So this is this angle that we're talking about, and it is 216.8 degrees. Angles to 1 decimal place. Now we also need to find this one, butterfly story, 360 minus theta. So 360 minus 36.869 is equal to 323.1 degrees. Question 3. Tan x is negative 3.4. Tan x is equal to negative 3.4 degrees. So now we have to get that angle there. Again, don't press the negative. The negative indicates the quadrants. So shift tan 3.4 is equal to, and I got 73.61. X is equal to 73.61 degrees. Right, now the question is, where, according to cast, remember, this is cast, where, according to cast, is tan negative? Now, this is where tan is positive, so it will be in those two quadrants. So how do I get this angle? It's again butterfly story. 180 minus theta, 180 plus theta, 360 minus theta. There's my angles. So 180 degrees minus 73.61 is equal to 106. So this is my final solution. This is not part of the final solution. That one is there. And then 360 minus 73.61. And that one is 286.4 degrees. There's my two solutions. Right, now you should try them first, and then you can mark them. First try them, and then you can mark them. Number 4, it's actually number D. Cosine x is negative 0.7. Cosine x is equal to negative 0.7 degrees. So first we get the key angle. Second function cosine, 0.7, don't press the negative, is 45.573. Draw cast, where is cosine negative? According to cast, cosine is positive in these two quadrants, so that means cosine is going to be negative in those two quadrants. So this is your key angle, 45, but it's not part of your final solution. So let me get this one then, 180 minus 45.573. So final solution, 134.4 degrees. And then this one, 180 plus 45.573. And this one is 225.6 degrees. That is my final solution, Right, the next one is number E. Number E, please try them now on your own and make sure that you understand them. So sine x is equal to 0.4. So second function sine, we first find that key angle, and mine is 23.58. Now we draw cast. Where is sine positive? In those two quadrants. How do butterfly story? How do I get those angles? This one is 23.6 degrees, and this one 180 minus, so it's 156.4 degrees. That's then my final solution. Number F. Tan x is equal to 1.8. Second function tan, what is the key angle here? 61.0 degrees. I've rounded it there, that one. Where is tan positive? There's the positive in those two quadrants. So that's why this one is 61.0 degrees, and this one is then 180 plus theta, so it's 240.9 degrees. That's my final solution there. G, cosine x is equal to 0.87. Second function cosine, so the key angle is 29.5. Draw. Where is cosine positive in those two quadrants? So that one is 29.5. How do I get this one? According to the butterfly story, 360 minus, and it's 330.5 degrees. Right, the next one, H. Sine x is equal to 0.9. Second function sine, my key angle is 64 27.2 degrees. Draw where is sine positive in those two quadrants. So how do I get this one? Butterfly story. So that one is 64.2, 180 minus, and it's 115.8 degrees. And then the last one, number I, tan x is equal to 0.512. Second function tan, what is the size of the angle? 27.1 degrees. And then where is tan positive in those two quadrants? So this one is 27.1, and this one will then be 180 plus, which is 207.1 degrees. So this is then the question on cast.